Alright, so I'm calling this particular program Program 4S since it's going to be a supplemental program to Program 4. So I've already created the Program 4S project folder and created the Program 4S source file, and I've also copied in our problem statement. And I think our problem statement, the way I've expressed it here, is sufficient enough for us to forego the pseudocode. So basically we just need to get the inputted score, and then based off of what range that score falls in, we'll output the appropriate message. So let's go ahead and start coding. So we'll do our includes, #include, IO stream so that we can do some input and output, and then using namespace standard, and then we can start writing our main function. So int main open paren close paren, open brace, close brace should be inserted automatically for you. Okay, so the first thing that we need to do is get input from the user. And the input that we're going to be getting from the user is an integer value, so that's going to be the score. So we can go ahead and declare and initialize a variable named score of type int. So int score, assignment operator 0, semicolon. And then once we have that variable declared, we can go ahead and prompt the user. So we'll go ahead and do cout and say enter an integer score between 0 and 100. Okay, and we'll put a period /n for new line character and semicolon. So once we have that prompt there, then we can read whatever they input from the keyboard by using cn. So cn, then use the extraction operator, and we'll say, oops, we should put the variable name here, so score. So that's the basic 3 steps we have for getting input from the user. We have to have a variable declared, then we can prompt the user with some sort of message, and then get whatever they inputted and stored into the appropriate variable. So once we have the score, then we can decide what range it falls on and output the appropriate message. So if the score is greater than or equal to 90 and the score is less than or equal to 100, then we would just simply output awesome. So we'll write awesome here and put the exclamation point. All right, maybe new line character too. All right, so if the score is 90 to 100, we'll output awesome. If the score is greater than or equal to 80 and score is less than or equal to 89, then what do we output? In that case, we output well done. Now, one thing that you'll notice here is whenever I'm writing these Boolean expressions inside of the parentheses here, I'm having to express score in relationship to both the lower bound and the upper bound since I'm writing out both. So it's not good enough just to put score in between 90 and 100. So many of you may be tempted to write this like so. So maybe we have 90 here and then do less than or equal to score, and then that operation there. So that may be the way that you think about it. You're saying, oh, well, you know, score here is greater than or equal to 90, and score is less than or equal to 100. Unfortunately, that particular type of syntax does not work. We have to do it like this. So make sure you're writing it like so. And also that you are, in fact, using the AND operation as opposed to the OR operation. Again, if you tried to use the OR operation, we could write in a score like 1,000, and it would qualify on this condition here. And while that would be, this part would be false, so saying we had an OR here, and that part would be false if it was 1,000, but yet you would still output awesome, and that's not what we'd want to have because it has to be on the range of 90 to 100. All right, so we have that, and let's do AND here. And let's see here. All right, so let's come down and do the next one. So if score is greater than or equal to 70, and score is less than or equal to 79, then what are we going to do? We're going to output average. Okay. And if the score is greater than or equal to 60 and score is less than or equal to 69, we will output bummer. And then finally, if the score is greater than or equal to 0 and score is less than or equal to 59, not 590 but 59, then we would, oops, let's see, I got a mistake here. See out and see out. We'll do sad times. And that's our basic program here. Again, you can have your return 0 statement here at the end. So return 0. That's not really required. If you don't put it in there, you'll probably get a warning, but it assumes that you're going to return 0 if you don't have that return statement in there. So that's our basic program. Let's go ahead and save this, and then we will build it. Now, you'll see here that we have these red squiggly lines under cout. For some reason or another, the new version of Eclipse CDT, the Indigo version, it seems like the code analyzer is very slow on indexing everything so that these errors are actually removed. Eventually, these things will go away, and I need to do a little bit of research and post why that's occurring. If it's just me and the way I have things set up, or if it's something wrong. I think it's something wrong with the code analyzer. This is a new feature within Eclipse CDT Indigo. So everything built okay down here if we look at our console. So whenever we built the program, it was fine. So let's go ahead and run this and ignore that for now. So it says enter a score between 0 and 100. So let's put in the score of 87. And it outputs well done. Let's do another one. Let's run the program again, and this time we'll enter in 55. And it outputs sad time. So it looks like it's working correctly. Now, one thing that I do want to point out about this program is that we construct each one of these conditions with if statements. So if. So anytime that we have an if statement here, it's going to go in and check each one of those. But we know that if we have a score, and that score is between 0 and 100, it can only fit into one of these conditions. It can only meet one of these conditions. So we're actually doing more checks than we should be doing here. So, for instance, if my score was, say, 100, it will still go in and check each one of these. And we can actually verify that that check is going on by interactively going through this program using the debugger. Before I launch the debugger, I want to make a few code changes. So on our lines where we have these cout statements, you'll notice that they end with this new line character, that /n. I want to get rid of that new line character and then come on the right side of our string literal and do the insertion operator and then endl. And so this endl is what we call an IO manipulator. And it works almost the same as the new line character. So it does, in fact, insert a new line. But the other thing that it does that the new line character, the /n, doesn't do is it flushes the output buffer. And what that means is any characters that we had from, say, the string here that were sitting there in memory waiting to be pushed out to the console will be forced out by this endl operation. So it's basically flushing all those characters, that string there, out to the console. And with the new line character, we don't get that. Now, when we run the program outside of the debugger, we really don't notice a difference. But as we run it, this code through the debugger, or use the debugger to step through this code, then we'll see that if we had the new line character in there, it wouldn't actually push all that text out to the screen as soon as we had executed that line of code. So on all these lines here, we'll go in and change this to endl, and you can do the same. Actually, I may do some copying and pasting here, make it a little bit quicker. Go back and remove these new lines. Alright, so we replaced our /n with endls. So let's go ahead and save this program and then build it. And this time, after we build it, instead of clicking on this button here to run it, we're going to click on the button to debug it. So we'll still be running it, but we'll be able to interactively go through this program. So go ahead and left click on that. And you'll probably get a little dialog box here that says confirm perspective switch. So you can go ahead and click on remember my decision on this. It's asking, do you want to open this perspective now? And the answer is yes. So anytime that we want to go in and do debugging, we want to switch perspectives. So go ahead and click on yes, and you'll see that the view here, the perspective, has changed. It looks a good bit different than what we were looking at previously. But we still have our code over here in this little window. We have a little window here for debug, and we also have a window here where our local variables will show up. Maybe I shouldn't use the term local variables, we haven't discussed that, but our variables will show up over here. We'll get to local variables soon enough. Alright, so what can we do? So our program hasn't actually executed yet. We're at the very beginning of the main function here, but we can step through or interactively go through this program line by line. So going back up here to the debug area, there's a button here that says step over. So hopefully you can see that button that says step over. Now if this little window is not showing up for whatever reason, you can go here to window here on the menu bar and then go to open perspective, show view, and then select a debug here. So once you select that, you should be able to see this window. Alright, so yeah, back to stepping over. So we're going to be using this button here to go through line by line and execute our program. So go ahead and click on that button, and you'll see now that we have a little green shading here on this first line in our main function. So we're about to execute this line of code here. So go ahead and left click again on the step over button. You can also use F6, so if you prefer to use F6, that's fine. So you'll also notice that after we executed this line of code here, we have score, the type of what score is, and the value showing up here in our variables view. So that's pretty cool to be able to see what our values, our variables are going to be, and also the current value of those variables. Alright, so the next thing we're going to do is execute this enter an integer score between 0 and 100. Now if we did not have this endl here and you kept the /n, then whenever we step over this line of code, so I'm going to go ahead and step over it, you wouldn't see that actually coming out on the console straight away. It may take a few lines of instruction before it actually flushes that buffer or pushes the string or the text out to the console. Alright, so now we're going to step over again, and this time we've got to input something. So we'll input the score 95 and hit enter, and now you can see up here in our variables view that the score's value has changed to 95. It was 0 and now it's 95. So now we'll do this test here. We'll test to see if our score is greater than or equal to 90 and our score is less than 100, which it is. Let me scroll down a bit so you guys can see that. And I'm going to click on step over. And so now, since we tested true for this, and we're now in the body of that particular if statement, we're going to execute the cout statement. So we should see awesome show up, and we do. But now what you'll notice is, since we have if statements in here, each one of these if statements will be tested. And that's not necessarily a good thing for this program, because we know that the way we set up these ranges, our score can only fall into or be test true for one of these conditions. So we're testing these unnecessarily the way we have our logic here. So it tests that one, then it tests the one for 60 to 69, and then finally 0 to 59. So all those are unnecessary tests, and then finally it gets to the return 0, and then we're pretty much done with our program here. Okay, so let's switch perspectives back to our normal editor. So up here on the right hand side we have the debug perspective, but if we go over a little bit you should see like two little arrows. It almost looks like our extraction operator, but it's not. Just left click on that and then left click on the C/C++, and that will switch us back to the original perspective that we had for editing C and C++ programs. So we'll do that, and we can close this little error message here, so ignore that for now. And we're back here to our code. So what we're going to do now is actually change our code a bit so that we're not testing each one of these conditions. We want to write this so that as soon as we test one of these conditions and that condition evaluates to true, we don't want to test any others. And the way that we can do that is using the multiple alternative else if. So after this first if, we can replace the rest of these with else if. And you can even replace this last one with an else if, but we can actually do one better than replacing it with an else if. If we've exhausted all other possibilities, we could actually write this last alternative as an else. So we can get rid of the test. We can say, okay, we've tested every other possible scenario. We know it has to be sad times if they didn't make the right score or whatever. So let's go ahead and save this and compile it, and we'll see the difference here. So let's save it and build it. So it's compiling and linking it. And now we'll launch our debugger again. So I'm going to go ahead and step over, just like we did before. So our little step over button here, our F6. Step over again. So we see now that we have our score here and its value is currently 0. Now we get our output. And now we need to step over. Now don't try to input any values here until you've actually stepped over the CN line. If you don't step over that CN line, it's not going to be trying to get input from the user. So we got to do that. Step over. So now we can input a value here, and I'm going to input the value, I don't know, let's input 85 this time instead of 95 and see what happens. So we'll hit enter and see what happens. So it's about to test this condition here. I'm going to scroll down just a little bit. So if the score is greater than or equal to 90 and score is less than or equal to 100, obviously 85 does not fall into that condition. So let's go ahead and step. And so it skipped over. It didn't go inside of this if statement here. So we had that if condition, but it didn't make it inside of the body because that returned a false value when we evaluated the expression here. Now it looks like we're going to qualify here, right? Because the score is between 80 and 89. So we'll step over, and you'll see, in fact, that it does go to the C out line. So we'll get well done here. And whenever I clicked on step over again, it took me all the way down to the last statement. So it skipped over all these other alternatives because the way we constructed that using the else if. So there's a big difference between using else if and if statements. If we have if there, it will test those. If we have else if, as soon as it meets a condition and executes the associated expression statements for that particular condition, it doesn't bother doing anything else. All right, so let's go ahead and stop this program. We can click on the terminate button here, and we'll switch back to our other perspective for the editor. And the last thing that we may want to do, I guess we could end up in a situation where someone inputted a number like -50, and -50 would end up printing out sad times, but actually that's not even a valid score. Our score is supposed to be between 0 and 100. So up here we could actually put in a test to check and see if the score is less than 0 or the score is greater than 100. Because we know if the score is less than 0 or if the score is greater than 100, we have an invalid score. So go ahead and put in an open brace on the next line. And here I'll just do cout and say an invalid score was entered. I'll say inputted maybe. and we'll say program will terminate. Okay. And maybe we'll use our endl. So let's see. Insertion operator endl, semicolon. All right, so once we do that, we can do our return 0. If you want to, we'll save this and test that out real quick just to make sure that that does work. So save that, build it, and then launch our debugger again. So let's go in here and run it one more time. So use our step over. We'll declare and initialize our score variable. And then we get this outputted to the console. And this time we'll type in, I don't know, -50 and see what happens. So it gets the value -50 assigned to score. Step over again. And you'll notice that this time we're testing the condition to see if the score is less than 0 or the score is greater than 100. So if either one of those conditions are met, then we want to say that we have an invalid score inputted. So that's going to be true. We'll get that outputted, and then we'll just simply terminate the program at that time. All right, so you can go ahead and click on terminate, and then flip back to our original perspective. So we've looked at several things here. We looked at using the else if as opposed to just using the if. We saw the difference between using if and else if. We looked at using the endl and what happens, why we would want to use endl as opposed to using the new line character. Usually if you're going to be using the debugger and you want to see your output immediately, I would recommend using the endl. So yeah, we've seen quite a few things here. So that's it.